This project was shortlisted for crystallography competition in Argentina. After participating in the day's competition, the project won the category of monocrystal of pentahydride cupric sulfate. The goal of this project is to obtain and grow seeds of the pentahydride cupric sulfate substance using the methods of humid crystallization, crystallization by evaporation of the solvent, and crystallization by cooling of a supersaturated solution. The obtainment and growth of the seeds of the salt was documented photographically week after week, and the mass and dimensions were registered. The pentahydride cupric sulfate, also known as chalcanthite, is a compound derived from copper that forms blue crystals that are water-soluble in water and alcohol. The salt crystallizes in the triclinic system, and its basic shape is a W-oblique rhombic prism. To start, a solution with an excess of dissolved solute was prepared, was put in a crystallizer, and the solvent was left to evaporate at room temperature. 2 weeks later, small crystals were obtained, and 2 of them were selected. The mass of both was determined and registered, and each crystal was tied on an end to a glass bar with a fishing line. 2 solutions of a 50% of supersaturation were prepared, heated until the complete dissolution of the salt, and once they were at room temperature, both selected seeds were submerged in the solution and were maintained suspended within the solution. After 7 days, the growth of both seeds was noted. They were extracted from the corresponding solutions, washed with distilled water, dried, and the mass and dimensions were registered. Next, in each solution, the mass of salt corresponding to the growth of mass registered for each crystal was replenished. The solution was stirred and heated and left to cool down to room temperature. Once again, each crystal was submerged in its corresponding solution, covered in plastic wrap, and left to rest. In some occasions, it was necessary to filter the solution because when working with commercial drugs, they presented numerous impurities that were insoluble and could affect the process of growth of the crystals. This procedure was repeated during 5 weeks for the smaller sized crystal and 7 weeks for the bigger sized one, achieving the results are shown. In both cases, monocrystals of significant dimensions were obtained. The monocrystal of the bigger size presents some irregularities on its sides, while the smaller one presents a perfect morphology with its flat sides truly reflecting the crystallization system of the substance. The results that were obtained are attributed to the fact that the crystals were suspended within the supersaturated solution, allowing all the surface area of each crystal to be in contact with the solution, and thus growing evenly.